So you learned about three different types of spectra that we can observe, and Kirchoff's laws are very general ways to explain these three different types of spectra. So remember that the three types are continuous, emission, and absorption. And of course, when we view these spectra through special devices called spectroscopes, one way to separate the light is just simply with a prism, so this is what we're illustrating now. They have very different appearances. The continuous looks like a rainbow, one color blends into the next. The emission spectra are very distinct lines of bright color, and the absorption spectra is like a continuous spectra, but there are black lines superimposed on that rainbow. So let's look at these three. So in the continuous spectra, we have some hot, dense gas or a hot liquid that's glowing, and the idea is that the light coming from that object contains all the different colors of the rainbow. And we can also see here that as we change the temperature of the light bulb, which is our light source here, the shape of this curve changes, which basically is talking about relatively how much of each wavelength of light is being emitted of all the different wavelengths. So as we raise the temperature, notice that the short wavelengths increase in intensity, and as we go backwards and lower the temperatures, it changes sort of the distribution of the light intensity. Now we go to the emission spectra. Now in an emission line spectra, we still have a hot gas, but it's a thin gas, it's not dense, and it's going to be made of particular types of gases. And so here, when we send this light through a prism so it separates, instead of seeing all the different wavelengths of color, we actually see very distinct lines of color, and these lines of color actually are representative of what type of gas has produced them. We say that these lines are like a fingerprint because for every type of gas it has a very particular emission spectra. So every time, for instance, you see hydrogen gas, it will produce the exact same wavelengths of light. So let's change from hydrogen to neon, and notice, of course, the colors or the spectral lines are completely different. Finally, in an absorption spectra, we start with the source of continuous light, we send it through a thin gas where some of the light is absorbed, and what we see then are, because the thin gas is only responsible for very particular wavelengths, we see the black lines at particular colors. We can change the gas here, which means we are going to end up changing the black lines, because again, this gas, which is the thin gas, which is responsible for the lines of black, again are like a fingerprint. So those are the very general explanations of how the three different types of spectra are formed, and we call these Kirchoff's laws.